Hello and welcome everyone to today's technical webinar on scaling still connections. My name is Yann Guéguin. I'm a senior regional engineer with IDEA StatiCa US, and I'm excited to be hosting you for today's discussion. And with me today, we'll have Andrea Costello. She's our technical manager, also in the US team. During this webinar, we will focus on integrating IDEA StatiCa with third-party global analysis software, specifically RAM structural systems, but for those of you that use a different global analysis software, the workflow shown today is super similar to the other software you might be using. So you'll learn a lot anyway. We'll talk also about the time savings that your team can achieve by designing smartly and leveraging these integrations. All right, so how to use GoToWebinar. As an audience member, you will see your GoToWebinar control panel typically on the right-hand side of your screen. You can type your questions into the questions panel. We'll answer as many as possible live. And if there is any that we don't get to, we will follow up afterwards. You'll also find 2 handouts available there as well, including the full PowerPoint presentation. Next slide, thank you. Today, we will do a quick summary of IDEA StatiCa's capabilities, and that will be followed by an overview of the integration connection design workflow. We'll also look at the batch design process for maximum efficiency when designing connections, and we'll talk about the data synchronization across models. And finally, we'll talk about, we'll go over important tips to get your work done faster. And at the end, we'll have an audience Q&A. All right. Quick introduction to IDEA StatiCa for those of you who are new to the software. We have 2 main modules, the steel module and the concrete module. We'll start with the steel. Main application is the connection application that will allow engineers to design and verify even the most complex joints. From a bolted to welded connection, this is going to be ideal for all sorts of configurations, moment connections, base plates, and even complex joints with irregular geometries. When we're looking at the steel members, you could use the member application. This will allow you to go beyond the simple beam calculations, enabling analysis of buckling, stability, and interaction effects under various load combinations. This gives engineers confidence in their designs, especially for non-standard cases. On the concrete side, the application is called Detail, and it is focused on the local zones of a concrete structure. So we could talk about areas like corbels, frame corners, deep beams, or regions around large openings, places where the stress flow becomes nonlinear, and simple hand calculations or spreadsheets checks just don't give us the full picture. The other aspect of this is the foundation design module within that detail application that can be combined with the steel application to handle the steel reinforcements in your concrete block. And I will pass over to Andrea.
Right, perfect. Thank you, Jan, for this introduction. Yes, as Jan mentioned, you have the handout available in the GoToWebinar, so you can follow this presentation using that PDF, and I have some links there that can lead you to more information or even videos. Okay, so let's start with the technical portion. Apart from the apps that Jan mentioned, IDEA StatiCa has an application to communicate to other analytical apps, like the ones I'm showing in this screen here in this first square. Okay. So today we'll talk about Checkbot in more detail, right? But here's the overall process for an integrated connection design. From the analysis application that you're using, we can export the structure to Checkbot, right? The geometry and loads will be imported into Checkbot, and then later Checkbot will group the connections by typology and cross sections. Within these groups, a reference connection is defined, like in this case, which will be the parent connection. This is the only connection that you will design for the group, and later the application will apply it to all the joins in that group. Okay. We can select to design the group for the critical load effect only for the joins in that group. I'm going to show you that later. Then after calculating the group, you will see the pass or fail status in this list, right? And finally, from Checkbot, you can get a report for the selected connections and generate deliverables like IFC models or 3D drawings, and even this IDEA StatiCa viewer link, right? So again, I'm going to show you this process using RAM structural system. Okay, so let's talk a little bit about RAM structural system. This application is a software commonly used for buildings that have similar geometry along their height. That means similar connection typology in every level. With IDEA StatiCa, we'll be able to identify the common typologies and design the connections by groups. So this type of structures layouts make it perfect for Checkbot batch design. So you will see it today. I will follow the 4-step process during demonstration. And for NDA reasons, today I am only using a general example of building a structure that has this more than 400 connections. Okay, so this 4-step process is first step, import the structural system model into Checkbot. The second step is to prepare the Checkbot file for the connection design. The third will be the group and batch connection design. I'll show you some tips and tricks, and finally how to generate these deliverables. And that means creating reports, 3D models, and creating the free viewer link. Okay, so let's start with the first step of importing the RAM model into Checkbot. For further details about this process, you have the link to the article, and later you can follow this process in using a trial version or even using the free version of Checkbot, which is available in our website. Okay, so first of all, let's learn how to install the plugin. Okay, once you install IDEA StatiCa, you can go to the beam links icon in the launcher. You can scroll down in this window, like the one that you're seeing here, until you find the RAM structural system line, and then you click on install. Okay, remember, as I said, that you can download a trial version and you'll have access to this plugin during the trial, right? Once installed, you will find an icon in your desktop. You can double click on that icon, as you can see it here in the screen, in this icon here. You double click, and then the application will ask you to browse to the RAM structural system file. Okay. I suggest making sure that the model has analysis results. It's important, so we bring the load combinations into Checkbot. Okay. There are some times that in your computer, in your configuration, you don't have this option to install icons in your desktop. So if that is the case, you can go to that application within the program files of IDEA StatiCa. Okay, so if you don't see it in your desktop because your configuration, you just go to your C drive, program files, and you will find this application. Okay, so you can call it from it. Then after you select the file from RAM structural system, the next screen that you will see is where you pick the design codes and create the project. Okay, so this is the actual Checkbot application. The Checkbot file folder will be saved in the same location of the RAM structural system model that you selected. Okay, the Checkbot file folder, it's as I'm saying, it's a folder. Okay, And that that file, you can later open it using the Checkbot application. In the presentation, I have the steps to open that file folder. Okay, in case you close it or something, so you can close it and then reopen that file folder, right? Once you hit Create Project, you will be in the Checkbot main interface. The next step is to click on the connection icon, as you can see here, this icon, okay? And that will launch the importing process. And after 2 or 3 minutes, you will see the structure and connections groups in the interface, okay? So you will see it, once it finished this importing process, you will see the list of connections. We'll see it in my screen after this slide, okay? That is how it works. That is how you import the structure. Okay, so the second step. Now that the whole structure is in IDEA StatiCa Checkbot, we need to prepare the model to get it ready for the connection design process. So what do I mean when I say prepare the model? So these are some steps that you probably need to follow to get the model ready to design the connections. First of all, we have the option to merge members. These 3 tips and tricks I'll show in the screen once I open Checkbot, but I'm going to just explain what are these steps. So merge the members. What does that mean? Sometimes when you bring a model from an analysis application, that application breaks up, for instance, columns when it finds a node, right? So for those cases, there are some times that you probably want them separated by that node and then design the column splice, right? But there are some other times where you need that column to be continuous. So if that is the case, when you need to have a column that is continuous, you can click on the members and then we have an option to merge them, okay? There are some applications like RAM structural system. In this case, for instance, if you see this beam here, it is continuous. It wasn't broken up by the application. So that one is correct. But in case that you want to break up a member, you can also do that. So we have 2 options, merge and divide from Checkbot application. I'll show you in the screen after this slide. Then later, because you probably changed the geometry of the node or the joints, okay? There are some times that you need to review or rearrange joint groups. You will see warning icon in the list of connections, and that means that you will see also this message here. You will see that it says typology or arrangement is not matching the reference connection. So you have the option to multi-select the connections that are not the same now in that group, and then create a new group. Again, why we will do this? Because you change the geometry of the joint, okay? Instead of being these 2 members separated, now they are continuous. Then the third tip that I wanted to share is that you can review the load combinations that were imported, and then you can select some of them and delete them from the group of load combinations, okay? So let me show that in the model, right? So first, let's review the merging option. So for instance, in this case, let's imagine I want this column to be continuous. I just click on this member or in this order, right? And then I hit merge. So you can merge the 2 levels, and then it's telling you that this will modify the items, or that they will be resetted. And then I click OK, and then that member will be merged. Okay. Again, this is important because in the connection design, instead of having two elements to be connected, now you'll have one continuous, and then you can connect these two beams into that column, right? So if I click here on this connection, that will lead me to that connection, and you will see the group that is where this connection is located. Okay, so this is on group 26. Now you can see that in this group 26, we have two connections that the arrangement is not matching. Okay, so if you click on one of these groups or one of these connections, you will see that connection highlighted here. So this is highlighted, and it's showing me that this is not similar to the reference connection. Okay. Sometimes we'll have structures like this one, that it's you have multiple members and multiple connections. So my tip here is to change it to wireframe view. So if we want to see the 97 connection, I click on it, and now I can easily see where is that selected. So the reference connection, if we go back to this transparent mode, you can see that this member is continuous, right? So that is why the connection 100 is different, because it has two different columns, two different members here for the column, right? So what we do, if I want to keep this as it is, I multi-select these three elements, and then I can remove it from the group, and then later I can create a new group for those connections, okay? And then a new reference connection will be created here, all right? All right, so that's one thing. Then at the top, when you import this structure, this is where you can see the summary of this structure. So how many connections I have in this, or how many joints I have in this structure, you can see it here. We have 483, okay? And then this is a summary. In this case, I started already to model some of the connection, to run the analysis of some connections. So also is telling you what is the status and what is your advancement here, okay? All right, now let's review the loads. So if I click over the loads icon here, I can see what were the load combinations that were imported, and also load cases. So you can see this is the load cases, and then down here we have the combinations. Now in this column, we have all the combinations that will be used for the connection design, okay? So sometimes you are okay, you want to design the connections for all these load combinations. But if you want to delete some of them and you want to have half of it, of the load combinations, you can also multi-select them here and right-click and then delete them. Okay, that will be just deleted from this group. If you think again and you want to reinstall this combination, you can also drag and drop, right? So this is to review the group of load combinations that will be used for the connection design. All right. Talking about loads, when we are in these different groups, okay, we can also use this calculate load extremes, okay? So in this case, what the software does is that it will look the critical load effects for the group. And then in each of these connections, you have all the load combinations that we saw from this icon, right? But then it will look in the group what are the critical loads for each of them. So instead of running the analysis for all these load combinations that we saw from the loads icon, it will run just for the critical for that joint. So that can save time when we are running multiple connections at the same time, okay? But that is up to you. You decide what to do, if you just want the critical load effects or all the load effects, okay? Okay, so that is That is how you prepare the model for the connection design, okay? Remember that you can ask questions, and at the end, we'll answer those. Now that the model is prepared for this design, now we start the connection design process using the groups. So I'm going to show you this using a video. Again, I place the video in a YouTube link, so later or while I am doing this explanation of the video, you can see it and go and select what to see, right? Okay, so I'm going to play this video and explain the process of how to design a connection. Give me 1 second. All right, so the model is prepared. Now I want to focus on these corner connections. I can click on the connection or the joint, and that will lead me to the group. Then the only connection that I can design is the reference connection. That reference connection is going to be underlined. Now you open the connection. In this case, I am using the connection library. So I can place a connection that I used it before or I created before. Probably this connection was for smaller members. So what I'm going to do is review the design of that connection, go to the operation and modify this design. Remember that we can use the operations to modify the connection. In this case, I am adding more bolts in that shear tab. And similar here, I am adding more bolts, okay? Then I am modifying the stiffener. I'm going to delete them. I can just uncheck the operations and that will be deleted from this model. And then I am doing a calculation here. Why? Because I want to ensure that the connection that I'm designing is okay, at least for this joint, right? So I am reviewing the results. I am checking the form shape, and I find out that the web of the column is overstressed, okay? So I can see those hotspots due to the extended shear tab that I use there. So what I'm going to do is I'm going to modify this connection design. Now I'm placing these stiffeners at the position of the shear tab, right? Then I rerun the analysis and find out that it's okay. So I save this connection, go back to the main interface, and then I want to calculate the entire group using that design. So I calculate all, then wait for the status of all the connections, and I realize that that most of them were failing. You can see it here. I'm just putting some stuff here so you can see it in my screen. So I review all the connection status by clicking on the connections, and then you can see the status in this area. In this case, the connection is overstressed, okay? And what I am doing next is that I'm going to review the connections, why that was happening, right? So I am turning on the loads in the screen. And then what I realized there when I was reviewing this connection, let me put play again, is that some of those joints, they have a moment force, and I designed it for a shear force, okay? So most of them, that was the issue. So I reviewed the connections, and all of them, they have moment force. So what I'm going to do there, I'm going to remove these connections from that group and then create a new group to do a moment connection now for those joints, right? So you can multi-select connections in this case. I'm reviewing there that it's the same problem for all of them. Multi-select, remove from group, and then creating a new group. Now in this group, I'll have a new reference connection. Create new group. Yeah, we're going to reset the connections. And then now connection 56 is the new connection. So I open that connection. And yeah, you can see here this moment it has multiple loads in that member, and that shear tab wasn't enough for a moment force, right? So I'm going to start modifying this connection. First place, I'm modifying the shear tab and then deleting that shear tab that I had before. Now I am using the connection library to find a design for only these two members, okay? That is a possibility. I found this connection, that moment connection, and then I apply it. In this case, I'm using a parametric template. Then in a parametric template, it's helpful because you can just modify these parameters that you are seeing in the screen, and easily you can change the design, okay? So I am adjusting the details using these parameters and everything is changed. Then I run the analysis again, just to check if this first iteration is fine. I am reviewing the stresses and looking at the load paths to see what can be useful in this case. So I am realizing that I have just one, some stiffeners just in the back part of the column. So I am adding stiffeners in the front side of that column, extending the shear tab a little bit so it doesn't clash with the stiffener. And then I am saving this connection, go back to the group 35, and then calculate the analysis for all of them at once. You will see the status of the analysis in the bar, right? And now we can see that only 4 of them are failing. But the difference in this case is that it's saying plate clash warning, okay? What does that mean? In this case, probably the size of the members were different, okay? So again, I am redoing this process of removing them from the group and then creating a new design for that new group that I'm going to do, okay? Selecting all of them, remove from the group, and then create a new group. A new connection, a new reference connection will be created. I open that connection, and then I realize the issue. See that this shear tab is clashing with the member. I am reducing the number of volts, and then everything is okay there. I calculate in this first iteration. I realize that that is fine. I save the connection, go back to Checkbot, and run the analysis for the entire group. Okay. Now, all the connections in that arrangement are okay. As I said, I placed this video in a YouTube link so you can review this process again. It's just a demonstration of how you can design a group. Probably I should like check the forces before, right? So that is part of preparing the model, but I wanted to use this example to show you how to create new groups for these different conditions that you will find in different typologies, right? In the same typology, sorry. All right, as you saw, I use connection library that it's implemented in the software, right? Let me go to the next one here. So I use the connection library that we have in the software. Remember that the connection library helps you to reuse some of the details that you design, that you save it if you are a user of IDEA StatiCa, or you can use templates from our predefined database, okay? But there are some times, like in this case, I'm going to play this video, that we don't find connection in the connection library. So what we can do in this case is we have 3 HSS coming into a Y flange column. So I don't find anything here. what I'm going to do is look for a connection in the web connection library. So I'm going to define the geometry, in this case, as I have it in that model. I can define the position of the members, the cross-section of the members. I'm selecting all the beams to be HSS. I create a new member here, put it in the correct position, and then finally I hit search. This will help me to find a connection for that specific geometry. And then you can filter these options by the design code, or you just can open it and then you save it in your connection library. That's what I'm going to follow next. So I decided to use, you can see that they were almost similar, all of them. You will see the design code in the right side of the screen. You can see here that this is Eurocode, so I then change it to one that it's AISE, but it doesn't really matter in this case because I'll save it in my connection library. So finally, I decided to use that connection, and then you can open this connection in your desktop, okay? So the process is to open that connection. Okay, so it opens in IDEA StatiCa Connection standalone version. Let me just jump into the part where it matters. Oh, there you go. So now we have this connection in IDEA StatiCa, and then I can hit publish in the top bar. So I published this connection in my personal data set, and then go back to the checkbot connection. Publishing process was successful, and immediately I can go back to the connection that I was designing and then propose a connection, and now that connection will be there. Okay, so those are the cases where you don't find a specific connection and you don't want to start from scratch, right? Again, these connections probably are different for, like, they were designed for a different size of HSS, right? So, but the easy part is that you can go to these operations and modify some properties, but at least it helps you to not start from scratch, and you can save some time finding out what type of operations you will do or you will use. All right. So those are some tips and tricks for these cases where you don't have a connection. All right. The video is there so you can follow the instructions for your projects. Okay. All right. So after you go through all the groups or all the connections that you want to design from that structure, I'll show you how to create deliverables. Okay. So I'm going to show you 3 options that we have in the software to create high quality deliverables. The first thing is that you can create multiple reports from Checkbot. So in Checkbot, because we have all the connections from the structure, you can select what connections you want to get a report, and then you can create a report from the interface of Checkbot. I'll show you that in the model. Also, we have the option to select all the connections from the model. Let's imagine we have all the connections designed, right? And then we can create one single IFC file. That will create a single IFC with the relative position that you brought from your other analysis software, right? And then you can open this IFC in a Beam application. I'm showing here this example. This was open in Tekla Structures or in Revit, okay? It's not very clear here, but you will see all the connections there. And this can help you for coordination, right? I have seen that some users are using this model to place it in the same structure in Tekla, right? So it's basically helping you to coordinate the position of some elements in the structure. Okay. Similar here in Revit, you can overlap the structure that you have without connections and then coordinate the position of the elements in that structure. Okay, so that is one option that you have from Checkbot. Create a single IFC with all the connections in the relative position. And then finally, you can also create an online viewer link to some of the connections. Well, depending on what connections you want to share. In the presentation, I have some links here, but if you click over the over this link, you will find the viewer for multiple connections from that structure that I am showing today. But let's see how you can get this from your Checkbot file. Okay. So first, to get the reports, you should go here to this tab that it's called Report. Okay, let's wait for a second while it loads all the connections. Okay. So now I am in the report area. In this, you'll have this list of all the groups, all the connections in this model. And then from here, you will see what are the connections that were designed, that the status is fine, right? And then you can select from here what to include in that report. One option can be to select the reference connection, for instance. So you get one connection from every group, right? You can also right-click over the connection line, and then you can remove all the selected connections, or say add all the calculated ones, or simply as add all in that report. Okay, this is only the setup for the report. Okay, so if you scroll down, I can go to the other groups here and say, okay, I want to add this and this. So here, as you can see, I am selecting just the reference connections from these groups. Okay, I can scroll down here and see all the other groups and all the connections that were designed or not, right? So you can pick to include that, and so on. All right. Now, after you select what connections to include in this report, you decide if you want just one-pager report, the detailed report. That means you have all the formulas or all the different stresses, contours, all the details of that calculation, right? Obviously, this will create a super big report. In this case, I selected the brief report, or the one-page report. The brief one, it's going to be only a table of the connections, and it will show you the status. After you select that, then you can hit generate, and then you have the option to create that document or PDF. Okay. In the handouts, I share one report that I created with the one-pager option, so you can review what we are delivering there in that report. Okay, so this helps you to get the report for multiple connections from a single source. Okay, all right, now let's talk about the IFC. So for the IFC creation, you can say, okay, I just want some of them, or I want all of them. So if you want all of them, I suggest right-clicking over the connections line and selecting all, right? Then you select all, and then you use this drop-down menu, and you click over the first IFC option. That will create one single IFC model. There is the other option to create multiple IFC files for each of the connection that you selected. Okay. Then finally, if remember that you can multi-select from here. So I can click on them, then press Control, click on different reference connections if you want, or some of the connections that are in this group. I'm selecting some of them here. And then let me just select the last one of the ones that I have here, right? So I select them, and then I can hit Viewer. Once you hit Viewer, it will create a link with all the connections that you selected from this list, okay? It will take a second. Why? Because it's exporting all these connections to this viewer. But I have this one ready here, okay? This viewer is a free application. If you don't have IDEA StatiCa, or if you are reviewing a report from IDEA StatiCa, you can create your basic account. In this basic account, you have the access to this free viewer, okay? What you can do in this free viewer, oops, it's creating the one that I was, that I just clicked. What you can do in this viewer, okay, if you multi-select some of the connection, you can select what to see here. Then from this top bar, you can share the link that we are seeing here. We can export this model to 3D WG file. So that's a 3D CAD file, right? You can even export this to IDEA StatiCa. So you want to use this model and export it to IDEA StatiCa. You can export it to IFC, or you can explore similar connections design in the web connection library, as I did in the other example, okay? Another useful thing from this is that you can see the information of this connection. So you can see also the load effects that were used for this report, for this connection, okay, design. So again, this is useful if you want to share also this link in the report, okay, so they can look at the 3D model and see what were the load effects used in a more graphical way. Then here we have the blades. So you will see the list of blades that were used. And then you can click over the plus icon, and this will generate this drawing. Okay. And also you see all different details about this connection from this drop-down menu. So this is really useful to share with someone that it's just reviewing the connection, and they have this way to visually review the connection. All right. Okay, so I guess that is what I wanted to show in this demonstration. Let's just reiterate on what we saw today. So first of all, we can save a lot of time by importing a model and loads that you already worked on. You already modeled that in your analysis software. So let's avoid manual inputs and errors and use the Checkbot integration to import this information. Checkbots save you time by grouping the joins by typology. So this will do an automatic grouping for you. Connection library, as you saw, can help you to reuse models and save modeling time. Then the calculate all option for groups that we saw helps you to populate the design to all the joins in the group and run the analysis with a single click. And I didn't show it in the screen, but when you hit calculate all, then later you can jump into another connection and then open it and start the modeling. So you don't have to wait until it's finished. It can work in the background, okay? Finally, you will save time by creating high quality deliverables from a single source, okay? So it's quick and easy to create these reports for multiple connections. So you can see here that we designed multiple, obviously, shoe tabs. Like this was the typology that was the most repeated, and also this one. But also we are looking at joints that have multiple members, moment connections, bracing connections, and even base plates. Okay. So that is from my side. Now Jan is going to share some more information about today, and then we jump into the Q&A.
Thanks, Andrea. Yes, very good presentation. Well, thank you everyone for joining us. So if today's example sparked some ideas, or if you see opportunities to improve your own workflows or highlight a project that you're working on, I would love to continue the conversation. You can get in touch with us through email, connect with us on LinkedIn, and you can also try some of the features that you saw today with your own trial version, free trial version. We are going to be going to a few events in the next few weeks. Today, actually, two of our colleagues, Catherine and Johan, are at the SEF Utah. I'll be going to the SEF Indiana next week, and I'll be doing a presentation in Kansas on March 11th. Our next webinar is going to be on March 25th. It's going to be hosted by NCSEA. It's entitled Steel Connections for Industrial Structures, Substations, Pipe Racks, and Supports by IDEA StatiCa. All right, let's take a look at a few questions that we got. Andrea, there was one I wanted to ask you.
Yeah.
How is the reference connection of a group chosen when you are in Checkbot and you have a default reference connection? And can you change this?
I'll start with if we can change it. Yes, we can change it by clicking over the group title, and then you can select the connection that you want as a reference connection. So you'll have more information about this group from here, and then you select it. And what is the reference connection? I don't have the exact response, but from what I have seen is that it's the first connection, like number. So, but I can double check that.
Yeah, I think
you can definitely change that. Yeah.
I think it's somewhat random, the way it's selected among the group, but you can change it afterwards. How do you update Checkbot? So just was the question. How do you update Checkbot when the RAM file changes member sizes or framing layouts?
Yeah, so in that, for RAM structural system, it is just one-way import. So if you see here, we have the structural model area. I'm showing my screen, right?
Yes.
Oh, yes, perfect, yeah. So in this structural model area, we have a synchronize icon. This is not available for RAM structural system because it's just one way. However, for other applications like STAT, ETABS, and SAP 2000, we can synchronize that information. But unfortunately, for RAM structural system, it's just one way.
There's more questions coming in. One that came up often was the export of DNLS connections to a detailing software like Tekla Structures or SDS2. I'm just talking again about what we can export.
Yeah, so we can export an IFC file. So that'll be the way to send that information to the detailers. So that is one. Then the other is, as you saw, like clicking over the viewer, and then in the viewer, you can export it to a 3D drawing. So you have that option too.
Very good. There's a question about someone that has a very specific example of receiving SAP 2000 files, and they would like to export this or have this into IDEA StatiCa. The engineer does not have, the other engineer does not have IDEA StatiCa, and that team does not have SAP. Can you just talk about the free Checkbot version allowing transfer of information for people that work with engineers or detailers that do not have IDEA StatiCa?
Yeah, sure. So for those cases, you can create this basic account that I was talking about. That basic account, let me just look for the website that we have here. That basic account gives you the ability to use Checkbot. Let me just bring this screen here. So you come here and it will tell you the step by step. But for the Checkbot application, once you install IDEA StatiCa and you log in with that free account, let's say, or basic account, then you just go to Beam links. And if you have IDEA StatiCa, sorry, the source application installed, then you can install the link to it. Okay. And then you can follow the same steps as if you have IDEA StatiCa as a licensed user. It will be the same process. Okay. However, the only thing that you cannot do is opening the connections, of course, or the joints. Probably we just share the basic. If you Google IDEA StatiCa basic plan, you'll find this website. But we can put it in the chat or share it later.
Yes, agreed. Several questions, people asking if we can do webinars showing the exact same thing, or similar thing, but for SDS2 or SAP 2000. It's really going to be the same workflow. You can find all the tutorials to integrate with the different software that we integrate with, exactly through the link that Andrea is showing just there. So under BIM and workflows in the top ribbon. And as soon as you're in Checkbot, there's really no difference whether it came from ETABS, SAP, Revit. It's going to be the exact same thing. So we just picked RAM as an example, but same workflow can apply for other software.
Yeah, you can see all the tutorials that we have here. It will be the exact same thing. It's just what it changed is how we link to this software. Like in this case for the SAP 2000, you install the plugin with it within the SAP application, and after all, you will see the same interface here in Checkbot. Okay. But we definitely can do some other examples with other applications if that is requested.
Can you talk about the calculate loads extremes button? Is it running the critical loading for each connection, or is it selecting the worst case for all the connections?
It's going to select this option when you are on the group. It's going to select the worst cases for each joint. Okay.
Yes.
And then also in the presentation, in the PDF that we share today, I had this slide that I just hid it in my PowerPoint, but in the PDF is there. And this leads you to a link where we explain the selection for the connections. Okay.
We don't want you to run envelope load cases anymore when using these integrations. So it's always going to be per connection that you're going to be running the connections and for the local loads. And that will allow you to optimize your connections as best as possible. Running a little low on questions, but there's some that were asking about recording of this presentation and PDH certificates. Just as a reminder, PDH certificates will be sent in about a week by GoToWebinar, so you'll get that by email. And the recording should be posted tomorrow through the same link that you used to register for today's presentation. So if you missed some parts, you'll be able to find it there. And it'll also be on YouTube, I believe, on there, right?
Yes, we're going to send this to all the attendees and the non-attendees.
Question regarding the Reset 3D workflow. So it is a little more complex to integrate with Reset 3D than with all of the other software, at least for the loads part. Reset does not have an open API, and that makes it difficult for us or impossible for us to actually grab the loads directly from the SAF file format that they export. So you'd have to send your loads from Research3D to Excel, and then from Excel to IDEA StatiCa, so it's one extra step. It's not on us, and we would really recommend you to contact Risa if you're a Research3D user, for them to make this API open. It has to come from them, and there's nothing that we can do until they make it public and open. And I believe that's it for the questions.
All right.
Thank you, Andrea. Thanks everyone for having joined us today. And our next webinar will be on March 25th, in just a month.
All right. Thank you so much. Thank you, Jan.